We are wrapping up Chapter 5 with 5-8, applying special right triangles. Take notes and do the check it outs.
We have two learning targets today. The first, I can justify and apply properties of 45, 45, 90-degree triangles. And then we're also going to look at 30, 60, 90-degree triangles.
Okay, we have two theorems with relation to the two different kinds of triangles. The first is about 45, 45, 90-degree triangles. And what does it tell us? It tells us if we have a 45, 45, 90-degree triangle, the length of the two sides associated with the 45, or the two legs of the right triangle, I should say, here and here, are going to be equal. The length of the hypotenuse is going to be the length of the two legs times the square root of 2. And when I do problems, I usually make a little table. So I make a little triangle with the three angles and the ratio of the lengths of the sides to those angles. So the two legs are going to have a size A. That means the 90-degree or hypotenuse is going to have a length of a square root of 2. And I make this table when I do problems, and as we get into the problems, you'll see why this makes a little bit more sense. Maybe might help you. All right, a similar theorem for 30, 60, 90. It's about the ratio of sides. So this one says that if the side opposite your 30-degree angle, so here's your 30-degree angle right here, the side opposite, that's really actually a very ugly color. So the side opposite that is here, it has a length S. The side opposite the 60-degree side, which is this one, is going to be S times the square root of 3, and then the hypotenuse, which is the side opposite the 90-degree angle, is going to have a length of 2S.
And if you forget, as far as which is the shortest or longest side, keep in mind that 30 degrees is smaller than 60 and 90, so it has to have the shortest side. So that's why everything's based off of the 30-degree angle and the side opposite that. These other two sides have to be larger.
All right, so I have a similar table that I make for my 30, 60, 90. Here are my angles, and this is the ratio of the side opposite that angle. And when we work through some problems, you will see hopefully how that helps.
So speaking of which, let's work through some. So we have a 90-degree angle here, 45, which means this is 45, so we have 45, 45, 90. And let's figure out what x has to be. So we know this has to be 8. The other side has to be 8 also. Okay, so again, a 45, 45, 90-degree triangle. Hypotenuse is going to be the side length times square root of 2, so x equals 8 square root 2. For B, again, we have a 45, 45, 90. How do we know? Well, we have an isosceles triangle, which means the base angles must be the same, so they both have to be 45 degrees. And here we have the hypotenuse is 5. So for the second one, again, we have, using the table Ms. Briscoe was talking about, 45, 45, 90. A square root 2. A is the same as our x, length of our two sides, our two legs. Hypotenuse is 5. So we know 5 must equal a square root 2 or x square root 2. Divide both sides by square root of 2. And then you have to simplify, simplest radical form. Multiply top and bottom by the square root of 2. Leave it as 5 square root 2 over 2 for our value for x. If you got questions on simplifying or putting your answers in simplest radical form, please be sure to ask.
All right, so here are some examples. Find the value of x. Make sure your answers are in simplest radical form. That means no square roots in the denominator.
So now we have another example. Jana's cutting a square material for our tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches so it will hang over the edges of the table. What size square should Jana cut to make the tablecloth and round to the nearest inch? So for this one, let's draw a picture. Pictures are wonderful. So it's going to be a square. So we have our square. That looks very nice. And the table's diagonal is 36 inches. She wants a tablecloth to be an extra 10 inches on the diagonal, which makes our diagonal here 46 inches. Since it's a square, we're going to be looking at a 45, 45, 90 triangle. So let's fill in the table, write out our 45-degree angles and our 90-degree angles. So we have A and A for our 45-degree angles. And A square root 2 is going to be the length of our hypotenuse. So we can have an equation right here between these. We can set these two equal to each other. So 46 must equal A square root 2. And divide both sides by square root of 2. This case, we want to round to the nearest inch. So put in your calculator 45 or 46 divided by square root of 2. And you'll get it to be about 33 inches should be the square that she cuts. Or the side lengths.
Okay, so you're going to check it out. Tessa's dog is wearing a square bandana. I'm sure this is very relevant and fascinating. With a side length of 42 centimeters, what would you expect the circumference of the other dog's neck to be? Round to the nearest centimeter.
I'm glad you're reading. I can illustrate.
So a little hint on this, you're folding it in half to put it around the neck, so the circumference is just going to be the diagonal length of that particular bandana.
So now let's look at 30, 60, 90-degree triangles. And just to refresh your memory, when we were at the beginning, we have our different sides. Okay, so to refresh your memory, a 30, 60, 90-degree triangle, how the side lengths relate to each other. Everything's relative to the 30-degree angle. That side opposite 30 degrees is going to be B. 60 is B square root 3, and the hypotenuse is going to be 2B. So now let's figure out what X and Y are in this first one. Okay, so here again is why you're using this table, filling out 30, 60, 90 degree, B, B square root 3, and 2B. What we know now, we know the hypotenuse, length for that is 22. So here we have an equation we can set to solve. 2B equals 22, so B equals 11. So now we plug in B, our 30-degree side, X must be 11, and Y opposite our 60-degree angle, so Y would be 11 square root 3. Short and sweet. Now let's take a look at B. So we start again with our table, list the 30, 60 degree, 90 angles, relation to the sides. 30 degrees is B, 60 degrees is B square root 3, and the 90-degree side will be 2B. We know the side opposite the 60-degree angle is 15. So here's our equation we're solving. B square root 3 must equal 15. Divide both sides by the square root of 3. So B equals 15 over square root of 3. We get rid of the radical in the denominator, multiply both sides by square root of 3, or multiply top and bottom by square root of 3. And we get 15 square root 3 over 3. Simplify, we get B to equal 5 square root 3. Which then means our hypotenuse, which would be our Y will equal 10 square root 3. So this is X, and that will be our Y value.
Nice.
Thanks.
All right, so here are some problems for you to try. Remember, answers need to be in simplest radical form.
So, an ornamental pin is the shape of an equilateral triangle. The length of each side is 6 centimeters. Josh will attach the fastener to the back along segment AB, and that's drawn in, or the fastener fit if it is 4 centimeters long. Let's check this out. So we labeled equilateral triangle, so each angle is 60 degrees. This is bisected, so we have a 30, 60, 90 triangle. We know the side length are 6 centimeters. So again, 30, 60, 90, the side opposite 30 is length B. The 60-degree angle, side opposite is B square root 3, and the hypotenuse is going to be 2B. So in this case, our hypotenuse is 6 centimeters. So again, here's our equation. So we can solve for B. 2B equals 6, or B equals 3, which means that this side here, the length of that side is going to be 3 square root 3, or about 5.2 centimeters. We're looking at a fastener of 4 centimeters long, and so in this case, yes, it will fit because that length is 5.2 is going to be greater than 4 centimeters. So that fastener will work. Yay!
All right, so you're going to try this one. A manufacturer wants to make a larger clock with a height of 30 centimeters. So you want to find the length of each side of the frame, round to the nearest tenth.
So to summarize again, make sure you have these theorems in your notes and you know the relationship. Keep in mind, this is an isosceles triangle, which is why both sides are length L. They have to be the same. Base angles are the same. That's going to help you remember. And so hypotenuse is just going to be L square root 2. And then 30, 60, 90 triangle, everything's based off the side opposite the 30-degree angle. And so good luck. Bring any questions you have to class. Make sure you simplify your radicals.